Critical points are where the graph changes its concavity or direction. Extrema are points where the graph changes direction. The function has a minimum or maximum value, relative or absolute, at these points. A point of inflection is where the graph changes its concavity, but not its direction. And reminder that concavity just means the direction it's facing. So how this is like a downward facing parabola, and then we have an upward facing parabola. Right here, this point of inflection is changing from like an upward facing parabola to a downward facing one. So that change in concavity, whether it's face up or face down, that occurs right here at this point of inflection. Whereas this is a maximum, it's changing direction, it's going up, and then suddenly it's going down. Or this minimum, it's going down, and then suddenly it's going back up. So a point with the greatest value compared to the points around it is called a maximum value. Also called a local maximum. You can have a relative maximum or an absolute maximum. And the point with the greatest value over the entire domain of the function is the absolute maximum. A point with the least value compared to points around it is known as a relative minimum. And the point with the absolute least over the entire domain of the function is called the absolute minimum. So maximum and minimum are referred to as the extrema. They are points. Infinity is not an extrema because it's not a coordinate pair. So they are the tops of hills and the bottom of valleys. All right, so on these three questions, we are going to use the graphing calculator to find the exact value. We can see right here is the absolute maximum for this function graphed. Because it is an even function and the end behavior, both of the ends are headed down. So we know it will never go above this point. We have a relative maximum here as well. And then we have a relative minimum that we can find. So we're going to find the value for 3 extrema for this problem. It doesn't have an absolute minimum because it's headed down to negative infinity. But we'll use our graphing calculator now to graph this. So we'll go to y equals, clear out what's in there, and type in negative x to the 4th plus 4x squared minus 2x minus 4. And when we graph it, we'll see our picture here. We can see the 3 extrema. Reminder to calculate them, we hit second trace to pull up the calculate menu. And then I'm going to start with the maximums. So I'll choose option 4 for maximum. It's going to ask you for a left bound, right bound, and guess on your physical graphing calculator. If you're here in the app, it only asks for a left bound and a right bound. So I'm first looking for that absolute maximum. So I use my left and right arrows to move to the left of that absolute maxima. I hit enter. Now I'm going to use my left and right arrows to move to the right of it. Hit enter. Again, if you're on an actual graphing calculator, you would also have to move close to that point. Hit enter for the guess. And then in the lower left-hand corner, you'll see that it's telling you the maximum occurs at negative 1.53 if we round it 2 decimal places, and 2.94. So our absolute max, 1.53 and 2.94. And we'll repeat those steps. Second calculate, choose option 4 for the second maximum, the relative maximum we have over here. So again, I'm moving my cursor just to the left of it, hitting enter for the left bound, moving my cursor just to the right of it, hitting enter for the right bound, Again, on a graphing calculator, it would ask you for a guess. You can just move close to it and hit enter. Lower left-hand corner, it tells us that our relative max, or our local maximum, those terms are used interchangeably. Rounded to 2 decimal places would be, you know what? I forgot my negative on the other one, sorry. Negative 1.53 and 2.94. This one is at positive 1.27 and negative 2.69. Now we can find the relative or local minimum. So again, second trace to bring up that calculate menu. This time we're looking for a minimum value, so we're choosing option 3. Again, we need a left bound, right bound. So we move our cursor just to the left of that minimum value. Move it over to the right. Aim for on the calculator, move it close to it, hit enter for the guess. And we see that the minimum occurs at 0.26 rounded to 2 decimal places and negative 4.25. All right, so you will repeat those same steps for 2 and 3. So question 2, you've got to find a local minimum right here. And a local or relative. Again, those terms are interchangeable, so you may call it a relative or a local minimum and a relative or a local maximum. It doesn't have absolute extrema because it's headed up to infinity and down to negative infinity. On number 3, again, you will have a local max, a local min, and then this is not a max or min, it's not a point of extrema, it is an inflection point that we talked about up here where it's just changing concavity. So it is a critical point, but it's not considered to be an extrema. So you don't need to find that point there. But practice using your graphing calculator to find those values.